Here is a question about complex numbers, really. It says, use de Moivre's theorem to show that the cosine of 5x divided by the cosine of x is the same thing or is equivalent to 16 cos power 4x minus 20 cosine power 2x plus 5. Now, I'm not going to take this question all the way to the end, but I will bring you all very, very close to the end so that you just simplify the last part to arrive at what we would refer to as an identity. Okay, so this is some kind of an identity that the cosine of 5x divided by the cosine 5 is the same, the cosine of x is the same as what you see on the right hand side. Now, the issue here is the big problem here, the real thing that requires us to use de Moivre's theorem or to bring in complex numbers is this cosine of 5x, okay? So what we need to do is to find an expression for cosine of 5x in two different ways, okay? So one, we will use de Moivre's theorem based on complex numbers, and in the second instance we will make use of binomial expansion. Okay, so let's see how we go about this problem. All right, so first we will let a complex number z be represented by cos x plus I sine x. So of course, if you're asking this question, it means you have gone through complex numbers and you have a clue about what this means. All right, so let z, the complex number, be cosine of x plus I sine x. Sometimes we just write c's of x, okay? If that's the case, then z to the power of 5 can be expressed this way. So if we are taking z to the power of 5, then z power of 5 must be cosine x plus I sine x, everything to the power of 5. Now, by de Moivre's theorem, we know that this simply means we take this 5 here and move it in so that it is 5x there, cosine of 5x, and plus I sine of 5x. But how do we know this? This is not what the question is asking. We simply need to make use of the de Moivre's theorem. But just in case you do not know how to show that this is the de Moivre's theorem, to prove the de Moivre's theorem, the first thing you need to know is that cosine x plus I sine x could be expressed using Euler's form, which is e to the power of ix. So from de Moivre's theorem, I can first of all say that cosine of x plus I sine x is e to the power of ix, where the x here is the argument of the complex number. The x here is called the argument of the complex number, right? So if the argument is x, then the complex number can be represented like this, all right, in terms of e, or in terms of cosine and sine of x like this. So if this was theta, if it was cosine theta plus I sine theta, then we can express this as e power I theta. If this was cosine of k plus I sine k, then I can express this as e power I k. And therefore, because this one is cosine of x plus I sine x, this must be in Euler's form. We write this as e to the power of ix. Okay? And now, if we then have z power 5 equals that, then I can replace this stuff inside the bracket using that, all right, using the Euler form. And so I would write e power I x, everything to the power of 5. Now, using our laws of exponents, we know we can write this as, you know, the 5 just goes in and multiplies the power in there, okay? This the power law of exponents, right? So this just becomes e power I times 5x, okay? And therefore now this becomes our new argument. 5x becomes our new argument in place of x, and that means I can replace, I can write this back, but because now I don't have x, I have 5x, 5x replaces the x here. And so this can now be expressed as cosine of 5x plus I sine of 5x. This is how we prove de Moivre's theorem. But of course, to really prove it, we would need to show that this is equal to this. And this is something we learn in calculus under series expansion, power series expansion, or Taylor-Maclaurin series expansion. We can see how to expand this so that we show that it's equal to that, but we will not go into that. And so this is how we show De Moivre's theorem, which is to say then that z power 5 can be expressed simply as cosine of 5x plus I sine of 5x. This is good. So this is one way of expressing, of bringing about cosine of 5x, because I need this cosine of 5x. So I've seen that z power 5 can be expressed like this. So let's keep that in mind, and then we move on. Now we want to express z power 5 in another way. Okay, this time we're going to use binomial expansion. So by binomial expansion, again, I'm hoping that we know how to expand binomially. All right, we have, so if we expand this binomially, what do we have? We have that cosine of x plus I sine x, everything to the power of 5. Now, in order to make writing easier, we will replace cosine of x with c, and we will replace I sine x with is, just to make life easier. Okay, and so z power 5 then can be expressed as, it is power 5, so this is our n in binomial expansion, so we can have 5 combination 0. I hope we know what this means. So 5 combination 0, c power 5, I sine x, so cosine of x power 5, but I sine x power 0. Anything power 0 is 1, so I'm not going to put that here. All right? Then the next term is going to be 5 combination 1, cosine of x power 4, so the power of cosine is going to decrease, the power of I sine is going to increase. All right? So this is going to be plus 5 combination 1, cosine of x power 4, I sine of x to the power of 1. And then the next one is going to be 5 combination 2, cosine of x power 3, but I sine x power 2, like that. Okay, and then the next term we expect, because this is power 5, we expect 6 terms. So the next term is going to be 5 combination 3. So 5 combination 3, cosine of x squared, and I sine x power 3. Okay, the next term, so notice powers of is are increasing. So this was power 0, which is 1. This is power 1. This is power 2. This is power 3, the next is power 4, and then power 5. As on the other hand, the powers of cosine are going to decrease. So this is cosine power 5, cosine power 4, cosine power 3, cosine power 2, and the next one is going to be cosine power 1, and then cosine power 0. So what's the next term? Must be 5 combination 4, cosine x, so power 1, and is power 4, I sine x power 4. And lastly, we have 5 combination 5, cosine power 0. This was cosine power 1, so now cosine power 0, and I sine x power 5. Okay, so this is the expansion using binomial method. We have expanded c's x to the power of 5. Okay, now let's just simplify this. Let's go in here and look at the I first. Now, I squared, I is fine, but I squared is negative 1. I hope you know why I squared is negative 1, because square root of negative 1 times the square root of negative 1 must be negative 1. So I squared is negative 1. I power 3 is I squared times I, so therefore it's the same as negative of I. Hope that makes sense. I power 3 is I squared times I. So multiply by I here, then you multiply by I on this other side, you get negative I. Okay, so I cubed is the same as negative I. I power 4 is I squared times I squared. So I squared is negative 1 times I squared means negative 1 times negative 1, which is 1. So I power 4 is 1. And I power 5 is I power 4 times I. So multiply by I here and multiply by I on the other side. So then I power 5 is the same thing as I. So I'll write I power 5 is the same thing as I. I'm doing that because I'm going to simplify this expression. Also, the 5 combination R, so 5 combination 0, 5 combination 1, 5 combination 2, these are Pascal coefficients of a binomial expansion. So we know that this is power 5. If you determine this value, you can use a calculator to find these combinations, or you can use the long method. No matter what you do, you should find these are basically just the Pascal coefficients for power 5, which is 1, 5, 10, 10, 5, 1, like this. Okay, so those are the Pascal coefficients. So we will replace these values with the respective numbers here. So 5 combination 0 is 1, 5 combination 1 is 5, 5 combination 2 is 10, 5 combination 3 is 10, 5 combination 4 is 5, and 5 combination 5 is 1. Okay, so if we replace those, then z power 5 becomes, this is 1 times c power 5, so it's just c power 5. Okay, the next one is 5 c power 4 is. I'm going to put the I in front. So this is 5, so it starts with I, 5 c power 4 s. All right, that means cosine power 4x times sine x. All right, the next one is 10, and this one is just negative 1. So we're going to have negative 10 c power 3 s power 2, like that. All right, the next one is negative I, as we've stated here. So if we replace that, and this one here is also 10, so negative I will go in front, and then we have 10 c squared s power 3, like that. And the second last one there, I power 4 is just 1, and 5 combination 4 is 5. So we're going to just have 5c s power 4, like that. And lastly, that there is the same thing as I, as we've seen here. So this is the same thing as I, okay? And so, and 5 combination 5 is 1. So if we replace this thing, then I just have I s power 5, right? Like that, I s power 5. Now what I need to do is to collect the real terms. The terms that don't contain I in them are called the real values, the real part of the complex number z power 5. So I will collect the real parts together and then the complex parts also together, okay, imaginary parts together. Just like we have here, cosine is the real and then the term containing I is the imaginary term. So let's collect those, and I will have z power 5, and then I have this c power 5 here, and I have that it's a term that does not contain I on it. This one has an I on it, this one does not, and this one does not. So I can collect this term here, c power 5, minus 10c power 3 s squared, and 5c s power 4. I can put them together like this. So c power 5 minus 10c power 3 s squared, and then plus 5c s to the power of 4. That is the real part. And then now we have to add the imaginary part. The imaginary part contains this, contains that, and the last one. So I'll put the I out of the bracket. So I'll say plus I, okay, I into 5c power 4s, like that. And I'm just going to say minus 10c squared s power 3, and plus s to the power of 5. Now this would be useful if I was interested in sine of 5x, but right now I'm interested in cosine. So now we have expressed z power 5 in a second way. This is by means of binomial expansion. Please remember that this is just cosine power 5x minus 10 cos power 3x sine squared x plus 5 cosine x sine power 4x. Okay, so that's all that this means. So this is the value of z power 5 by means of binomial expansion, but we also found it by de Moivre's theorem. This is what we had found. So if we are going to compare this and that, those two results, we can only equate the real part, so this is the real part here, with the real part there. That is to say, that bit there must be equal to this bit over here. Okay, so we are going to just keep track of that. We will leave everything else and keep track of those two. So those two expressions must be equal. Let's write them down. So I'm saying that cosine of 5x there must be the same as, and this is what was inside the bracket on the other side, all right, for the binomial expansion. I can now write this in full using these values here. So I can write that as cosine power 5x minus 10 cosine cubed x sine squared x plus 5 cos x sine power 4x, like that. Okay. Next thing we need to know is we can use the Pythagorean identity, which is sine squared x plus cosine squared of x is always equal to 1. This is called the Pythagorean identity because we get it from Pythagoras, the triangle, right? Okay, so if that's the case, then sine squared of x must be the same as I can move the cosine squared of x to the other side, and so sine squared of x is the same as 1 minus cosine squared of x. That means I can write that as sine squared x is 1 minus cos squared x, and I need to do that because this question gives us all the terms in terms of cosine. There is no sine appearing. It means that everywhere where there is a sine, I have to remove it and try to replace with the cosine. All right, so that's why we are using the Pythagorean identity. And so sine squared, which is what we see here, we are going to replace it with 1 minus cosine squared of x. We also need to replace sine power 4x, but sine power 4x is sine squared of x, everything squared. So sine power 4x can be expressed as sine squared of x, everything squared. I hope you understand this. So all we need to do is now replace these back here. So where there is sine squared of x, I'll put this, and where there is sine power 4x, I will put this term here. All right, like this. Okay, so cosine 5x here must be equal to cosine power 5x minus 10 into cosine power 3x. And in place of sine squared x, I will put that. And also in place of sine power 4x, I will put this. All you need to do now is simplify this by opening the bracket. Okay? If you simplify this, open this bracket, and then simplify, put all the like terms together and so on, and then divide by this cosine of x, it should lead you to this result. So this is where I want to stop so that you have a chance to go through the question. Okay? Let me know if you have any further difficulties regarding this question. I hope you are able to understand. I hope you like it. If you're watching this video and you like it, please consider subscribing to the channel. Also consider liking the video and sharing the video widely with your friends so they can also get some help. All right, continue asking me questions. This was also a question from some kid in Nigeria. I hope that you liked what you saw. Thank you very much. I'll see you in the next video.